Hi, welcome to this lesson on Euclidean geometry, similarity and congruency. Let's have a look at question 2. We're given that NKLM is a parallelogram, so that's really important because we can use the properties of a parallelogram, with T being on the line KL. Okay, so there's that point T. The line NT, if we connect them, is then produced, which means it's extended out to meet this baseline ML here at a common point V. NT, this line here, intercepts with the diagonal MK at the point X. Okay, so that's all the information we'll be given, but because I know it's a parallelogram, I'm immediately going to add some properties here. So NK is parallel to ML, NM is parallel to KL, because it's a parallelogram. Also, KM is a transversal line between two parallel lines, NK and ML. So immediately on my diagram, I know that this angle here, NKM, must be the same as KML by alternate angles. Okay. And I know that these two angles here must also be the same. No, we don't have another diagonal. Okay, so that's all we can say there. We also know, because of parallelogram, that whatever side length NK is, that's the same side length as ML. And NM will be the same length as KL. That's important that we note down properties of quadrilaterals like parallelograms, rhombus, square, and so on, because it tells us a lot of information about the angles and the side lengths in relation to each other. And therefore, when we break those polygons up into triangles, we're able to work out similarity and congruence properties. Okay, so we want to first prove that xt, which is this distance here, over nx, which is this distance here, is the same ratio as xk, which is this distance over here. So let's do it in another color. Xk, this distance here, over mx, which is this distance here. All right, so how do I start a problem like this? Well, the important thing is that you want to try and utilize as much property of triangles as you can. And I can see quite a few amounts of triangles in this diagram. The next thing is you want to try and identify two triangles where these side lengths are involved somehow. Because if we construct those two triangles appropriately and show that they are either similar or congruent, then we can show that sides are in proportion or angles are equal. And because we have a proportionality factor going on here, we're most likely going to show that two triangles are similar to each other, right? And those two triangles that are similar to each other will produce this proportionality coming out of it. So that's the goal. That's the sort of technique we use when we want to prove ratios in geometrical objects, right? We try to break them down as far as possible into triangles where we can either prove similarity or congruency. Okay. So if I look at the red and blue lines here that show me what sides I need to look in proportion, I just need to play around and check which triangles will have most of those sides here. So looking at this blue and red, I want to try and maybe keep them grouped in that way. So if I look at this triangle KXT, that's got a blue line and a red line, right? And then if I look at this triangle here, MXN, that's also got a blue line and a red line. So that's sort of a visual cue to tell me, okay, maybe I can use those two triangles. Because even more so, they've got angles that are equal there as well. So that could also potentially help us. Okay. So I'm going to say, as my proof, I'm going to consider these two triangles. So consider triangle. Now, look at the way it's going. I think I'm going to go from blue to red. So I'm going to say K to X to T. And in that same fashion, I'm going to go blue to red. So triangle M to X to N. So if I can show that these two triangles are similar, then I've got xt, which is over here, divided by nx, which is over here. So if I do that division, it must be the same as xk, which is here, over mx, which is here. So you can see the pattern matches up. So that already tells me if I can show similarity there, then I'm all good. Okay. So let's have a look here. So in these two triangles, we have the following. We have this angle k here, angle. So we're looking at properties of, yes, parallel lines. Okay, yes, so properties of parallel lines. So I'm going to just draw out these two triangles so we can see it a bit better. All right. Okay, so here's K, X, and T. And then the other triangle is MXN. Okay, and then I'm just going to clean this up a bit so we can just work on this diagram more. Okay, so because we know these two sides are parallel, by alternate angles these are equal, and also by alternate angles these are equal. All right, so I know then that angle XMN is equal to angle XKT. Okay, and that is because NK is parallel to ML because it's a parallelogram and alternate angles are equal. Okay, so what I've shown is that this angle M here is equal to this angle K here. Okay, so far so good. So the strategy I'm going to try to use here is angle, angle, angle. All right, so now if you look at this triangle NXM here, if you look at this angle here, by vertically opposite angles, that'll also be equal here. So I can say that angle MXN is equal to angle KXT. Okay, so again, that is why vertically opposite angles are equal. Okay, so far so good. So I've got this angle is equal to that angle. So therefore, that means angle MNX must equal angle XTK, and this is by angles in a triangle, because these angles must all sum to 180. So these two angles have to be the same as well if they all sum to 180. Okay, so what we've shown here is that this angle is equal to that angle there. Okay, so therefore I've shown that triangle KXT in that order is similar to triangle MXN by angle, 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 because I've shown that angle K is equal to angle M. That was this first one. I've shown that this angle X is equal to itself here by vertically opposite angles, and this angle T equals this angle N was the third property I've shown. Okay, so because they are similar triangles now, I can compare them. So to get this ratio coming out here, what I can do is I can say that in this first triangle, XT divided by XK. So if I do that, in that same proportion, I must have NX divided by MX. Okay, and that almost looks like the one we want. So what I'm going to do is I'm going to multiply this side by XK, right? And then I'm going to divide this side by NX. So it's going to be XT over NX equals XK over MX. And that's exactly the thing we wanted to prove. All right. So that was using the properties of a parallelogram and also the similarity of those two triangles. Next, we want to show that triangle VXM. So VXM, so if I just extrapolate that triangle out here, so VXM, we want to show that is similar, rather, to triangle NXK, which is this triangle here. And already it looks a bit promising because look at this angle X here. That by vertical opposite angles already is going to be equal, right? This angle M and this angle K here we showed by parallel lines and alternate angles were equal. So already we've got the basis of showing how these are going to be similar. And then by sum of angles in triangle, those two angles must be equal. So I'm going to start my proof off as follows. I'm going to say consider, right, triangle VXM. Because they gave it to me, so I can write it like that. And triangle NXK. So then we have that angle MXV must be equal to angle NXK, and that's by vertically opposite angles are equal. Okay, so that's just this angle X I've shown you in the two triangles. Then I've shown that XMV, that angle, must be the same as NKX. And that is because NK is parallel to ML, and that is alternate angles are equal. And then lastly, that tells us that XVM must be equal to KNX, all right? So you can see when I'm proving the angles are equal, I'm not sticking to the strict, rigid way of writing it. I'm just involving the angles that are equal to each other. Therefore, at the very end, the angles are equal to each other. I then need to put that in the correct order. All right, so just a little subtle note. And again, that is by sum of angles in triangle, or angles in triangle for short. Okay, so therefore what I've shown is that this angle V here is equal to this angle N here. So I can start off with triangle V and triangle N. Then I've shown that this angle X here is equal to that angle X there. So I can put those next in order. And then angle M is equal to angle K. Okay, and therefore that is by angle, angle, angle. Okay, so we've shown that those two triangles are indeed similar. Lastly, if xt is 3 centimeters and tv was 4 centimeters, then calculate the length of nx, which is this one here. Okay. So we're going to need some idea of a triangle being similar to another triangle to maybe work out the missing side length here. And in this question, we've shown two different types of similarities. Okay. So we're going to have to look for one of the triangles, or one of the two pairing of triangles that we've shown are similar, that have these side lengths inside of them, xt, tv, and nx. Because if we can do that, then we can make use of the sides being in proportion to solve for the missing length. Okay, so we know that triangle VXM and triangle NXK were similar. We just proved it in the previous question. So I'm going to say we know that triangle VXM is similar to triangle NXK. Okay, so we start off with that. Then I can say the following, right? xt over nx, so xt over nx is equal to xk over mx. So where do I get this from? Okay, so if I come back here, okay, the very first question I was asked to prove was this exact expression here, xt over nx is xk over mx. So I took that. So whenever you're given a question and they've asked you to prove something, it's usually going to be used later on somewhere. So always keep that in the back of your mind. If you've been asked to prove something, it's most likely going to pop up somewhere. Okay, so I've just written that. So that was proven in the first question. Okay, and that was from the other triangle similarities that we looked at. So xt over nx is xk over mx. So that's what we've got there. Okay, so therefore, because I'm looking for the side length nx, what I'm going to do is I'm going to make that the subject of the formula. Okay, so I'm going to multiply it on top here. So I get xt equals nx times xk over mx. Okay. All right, and then to get nx by itself, I'm going to multiply by mx and then divide by xk. So nx equals that xt on the left-hand side times mx all divided by xk. All right, we were given xt as 3 centimeters, so that's 3. mx, we weren't given that side length just yet. Okay. Mx here. And all divided by xk. xk is a side length here. We weren't given that side length yet. Okay, so these are the two side lengths right now that are stopping us from completing the question. So we need to think now, what other similarities of triangles and their proportion sides can we use in order to solve the problem? Okay, so what I'm going to note now, that this ratio mx over kx, or xk, whichever way you read it, right? If I can relate that to another similarity, then maybe I can solve the question. So we haven't used this similarity yet, okay, which is the one we've proven before. So can you see every piece of information they've asked you to prove is going to be used when you do a calculation question. So mx, right, over xk, so mx over xk, that is that correspondence here. So if we can use another correspondence of side lengths that we know to replace that ratio, then we're good. So it's going to be still 3 times. So mx over xk can be written as vx, this side length here, over nx. So why do I do that? Why do I choose that specific correspondence to go with? Well, Vx is the side length here, and we can work that out because that's 3 plus 4, which is 7. And Nx, well, that's what we're actually trying to find. So if I replace that now, and again, this reasoning here is because those two triangles were similar, so we use the corresponding sides to be equal or in proportion. So it's going to be 3 times 7 over nx. Now, look at this equation that we've got. We've got nx equals 3 times 7 all over nx. So this is the equation we have. Nx, so let's just write it out here, is equal to 3 times 7 is 21 over nx. Then if I multiply both sides by nx, I'll get nx squared equals 21. And then to get rid of that square, I can square root both sides. So I get nx equals square root of 21. And because I was given a unit measurement, I need to make sure I put that in. So there was quite a bit of logic going around here. But if you follow the logical steps in that whenever you have a calculation-based question, if you go back and look at all the things you needed to prove, those are the puzzle pieces you need in order to solve a calculation type question. So it's a very logical art form. You only get better at these the more you practice them, trial and error, looking for the correct triangles and employing the similarity properties in order to solve the problem. All right, so that's how we would do this type of question. I'll see you in the next one.